Bismillahirrahmanirrahim. Assalamu alaikum. Hello everybody. New video, new day. Welcome everybody. We will try to find limits of 1, 2, 3, 4, 5, 5 functions. Let us start with the first one. Calculate, let I and b be positive real numbers. Calculate the limit of x over a, integer part of b over x1, x goes to 0. Here we will try to find the limit at the left and at the right. When x converges to 0, so we can suppose first, we can suppose that x is less than 1 and greater than 0. And secondly, from the left, we can suppose that x is greater than minus 1 and less than 0. Why we are able to suppose this? Because the limit is a local concept. So it doesn't matter if we come from far, this will not change the reality. So the limit doesn't depend on how far we can start going towards the limit. For this reason, we have all the right to consider this interval or smaller than this interval, but close to 0, in the neighborhood of 0, both sides. If x is between 0 and 1, we will get 1 over x is greater than 1. If we take the integer part, this will be greater than or equal to 0, even if we put a, since a is positive. So the integer part of a over x is well defined. The same thing if we take x from here, we get a divided by x less than or equal minus 2, strictly less than, strictly greater, so this is strictly greater than 1. Greater than, and here strictly less than 1. Okay. So in both cases, they are well defined. This is very important. This is to give the fact that the integer part of b over x1, x is close to 0 is well defined. Secondly, let us calculate the limit from the left, the right. In this case, x divided by a, the integer part of b divided by x, when x goes to 0 plus, and we calculate the limit of x over a, b over x, when x goes to 0 from the left. For this case, we have b divided over x is less than or equal, x is positive, x is less than or equal to b over x, and greater than, strictly than b over x minus 1. Since x is positive and a is positive, if we times by x a, we get here x a, we keep the same inequality, x by a, and here x by a. We can cancel, and when x goes to 0, this goes to 0, so the limit goes to b over a. This limit is equal to b over a. For this reason, we have just the inequality which will be flipped. We take the inverse. In this case, we get x divided by a, the integer part of b divided by x is strictly less than x a b a minus x a, and greater than or equal, since x is negative, so we flip the inequality, we inverse the inequality, and here we have x a b x. We can cancel, and at the limit we have the same limit, so the two limits are equals and are equal to b over a. So the limit exists and it is well defined. How about the next? For this limit, actually, when we have integer part, think always to use left limit and right limit. We have the right to consider x once less than 1 and greater than 0, and in the second time we consider that is less than 1 and less than 0 and greater than minus 1. The limit of x divided by x1, x goes to 0 plus, and x is less than 1. In this case, this equal to the limit of 0 divided by x when x goes to 0. Here 0 because the integer part of, for example, 0.8 is equal to 0. So starting from 0.8, it is equal to 0, but here we have 0.8, 0.5, 0.2, and so on. The limit is equal to 0. From the right side, from the left side, we have the limit of x divided by x1, x goes to 0 minus, and here we take 0 between minus 1 and 1. In this case, we have the limit of what? Of minus 1 divided by x1, x goes to 0 minus, and this is equal to plus infinity. This means that the limit doesn't exist. This limit, we know that the limit of phi of x divided the limit of sine phi of x divided by phi of x when x goes to 0, if phi of x goes to 0, when phi of x goes to 0, this is equal to 1. We will use this idea, this formula, to carry on this limit. So we have the limit of n, m and n are real numbers. The limit of sine mx divided by sine n x when x goes to 0 plus both sides. This is equal to the limit of sine mx divided by mx times by mx. We replace mx by mx to have 1 divided by sine nx and x divided by nx. This is equal to this one. We can cancel, and it goes to m divided by n. Why? Because this goes to 1 and this goes to 1 using this technique. This is the limit. The fourth one, this one, from the high school, we are supposed to remember that cosine px minus cosine qx is equal to minus 2 sine p plus q over 2 x times sine p minus q over 2x. We are supposed to remember this. We can prove it in a very easy way. Using this technique, the limit will be found very easily. Once again, one thinks again, we can use L'Hopital to solve this one. We can use L'Hopital to use this one, and we can use L'Hopital to find the limit of this one too. But there is more mathematics than if we use straightly directly L'Hopital technique. For this limit, we have the limit of cosine px minus cosine qx over x squared when x goes to 0. This is the limit of minus 2 sine p plus q over 2x sine p minus q over 2x divided by x, the same limit. We have p plus q over, so we times here by p plus q over 2, and we get here p plus q. We do the same for this one, which will be p minus q over 2x, and here we have p minus q over 2. When x goes to 0, this goes to 1, this goes to 1, and we have here minus 1. This means that here we have q minus p. And we have here 2. It will be constant with this. So the limit is actually q square minus p square over 2. This is about this limit. The last one is a little bit more complicated. Using L'Hopital technique, we can carry on, but I prefer using more developed mathematics. We need to calculate the limit. Let us make some change on this formula. Cosine p over 2 cosine x divided by sine of sine x. This is equal to sine p over 2 plus p over 2 cosine x. Basic transformation. We have sine p over 2, which is equal 1. Cosine this one, it is equal plus cosine p over 2 sine p over 2 cosine p over 2 is equal to 0, so it is exactly this one. And this is equal to sine p times 1 plus cosine x over 2 divided by sine of sine x. And here once again we have basic transformation. We have sine p, and the sum, this is sum using a well-known formula. We will get cosine square x over 2 divided by sine x. Here we can write sine. The sine x is actually sine x over 2 plus plus x over 2, which gives us sine x over 2 cosine x over 2. Why we make this transformation? Because here we have x over 2. And here we are. We write this last formula. We will write it sine p cosine square x over 2. We make here the same thing, pi cosine square x over 2. So we have times p cosine square x over 2. We didn't nothing. here we have 2 sine x over 2 cosine x over 2 over this one, sine x over 2 cosine x over 2. We put this here, cosine x over 2. Here we have the famous formula: when x goes to 0, this goes to 0, so this goes to 1, because this is exactly this, and it goes to 1. This is exactly this expression, and when x goes to 0, this goes to 0, so this goes to 1. Here we have square here will be considered with this one, and when x goes to 0, this goes to 0, and this goes to 2, so the final limit of this is actually 1 times 0 times 1, which is equal to 0. This finishes this quick video. See you next time. Thank you very much.